guys, Mr. Backberg here. This is our test number 5 review video. Taking a look at these first 4 problems, it's all about using our calculator to evaluate some different functions. So in the first one, we've got f of x equals e to the negative x, and we're asked to plug in an x value of negative 3. So what we're going to do is we're going to use our calculators, and we're going to type in e to the negative third power. So here's my calculator. Right above our ln button is our e to the x, so we're going to go second, hit that ln button, and our power that we're going to type in is negative 3. And when we hit enter, if we go to 3 decimals, I would call this 0.050. For number 2, we're doing log base 4 of x, and the x value that we're supposed to plug in is negative 4. So we're going to be looking at log base 4 of negative 4. What we should recognize, though, is that this x value that we're plugging in is negative, and we can't do logarithms of negative numbers, so we didn't even have to bother typing this one into our calculator. This one is just undefined because we're doing the logarithm of a negative number. We can't do that. For our next one, we've got 1500 raised to the power of x divided by 6, and we're going to plug in an x value of 2. So we've got 1500. We're going to raise that to the 2 divided by 6 power. Now, one thing we could do is with this fraction, with this power, this is going to reduce down to 1/3. It really won't matter how we type this in if we go 1500 to the 2 divided by 6 power, or if we type in 1500 to the 1/3 power. We should get the same answer either way. So we've got 1500, and we're going to raise that to the power of 2 divided by 6, and we'll get 11.45 if we go to 2 decimal places. And our last one, we're doing 8 to the x plus 2 power, and the x value we're plugging in is negative 2. So we're going to go 8 to the power of negative 2 plus 2. Now this one we can simplify down a little bit. Negative 2 plus 2 is 0, so this is going to be 8 to the 0 power, and we don't need our calculator for this one because any number raised to the 0 power is just 1. If we take a look at number 5, we want to look at the graph of f to describe the transformation that's going to give us the graph of g. So for our f of x function, we've got 2 raised to the power of x, and then for g of x, we've got 2 raised to the power of x plus 2 minus 1. So what we need to do is we need to figure out what that plus 2 as part of the power does and what that minus 1 on the end of our function does. Now this plus 2, since it's part of the power, is going to be a horizontal shift, so either left or right. We just have to decide which one. Since it's a positive value, that's going to move us to the left 2 spaces. And now this minus 1 on the end is going to be a vertical shift, and since it's negative, it's going to move us down 1 space. So now let's graph these out to confirm. For our first one, we had 2 raised to the power of x, so 2 to the power of x. And then if we arrow down to our next one, this one is going to be 2 raised to the power of x plus 2 minus 1. So now if we graph these out, there's our 2 to the x, there is our 2 to the x plus 2 minus 1. So this red graph got shifted left 2 spaces, and it also went down 1 space. In the next section, we're looking at using the one-to-one property in order to solve some equations. In number 6, we're looking at some exponential equations, but in order to use our one-to-one property, we have to have the same base on our exponentials on the left-hand side and on the right-hand side. So we need to look at this 1 over 125 and try to rewrite it as 5 raised to some power. Now, since this is a fraction number, that power is going to have to be negative. So we have to figure out what negative power of 5 is going to land us at 1 over 125, and that's 5 to the negative third power. So now that we've got the same base on our exponentials, these are both base 5s, we can cross off those bases and we're just going to look at the powers. So we've got x plus 4 equals negative 3. In order to get x all by itself, we're going to subtract 4 from each side, and we get x equals negative 7. Now we can also use the one-to-one property with logarithms as long as they have the same base. These logarithms are base 3 logarithms, so we're going to cross both of those off and just look at what's inside of the parentheses. So we've got x squared minus 12 equals 4x. Now this one's a quadratic with a first powered x term, so in order to solve this we need to have 0 on one side. So we're going to subtract the 4x over to the left-hand side. So we end up with x squared minus 4x minus 12 equals 0. And now that we've got this 0 on the right-hand side, we can either try to factor or do the quadratic formula. I'm pretty sure this will factor out into x minus 6 and x plus 2. And now that we have it factored out, what we're going to do is we're going to set each factor equal to 0. So x minus 6 equals 0. We'll add that 6 over and we'll get x equals 6. And if we take that x plus 2 and set it equal to 0, we get x equals negative 2. Now technically we should check our answers. We should plug them back in. And the one I'm worried about is this negative 1. Can we safely plug this back into the logarithm? Well, if we were to do that on the right-hand side, taking that 4 times negative 2, we'd get negative 8 inside of parentheses. And we have to remember that we can't do logarithms of negative numbers. So this x equals negative 2 isn't actually a solution. The only one that actually works when we plug it back in is x equals 6. Taking a look at number 8, we've got an interest problem. We're given a principal amount of $7,250, and we're going to invest that at a rate of 6.5% for 20 years. In part A, this one is going to be quarterly, so as we start writing out this formula, the n value that we're going to be working with is 4, since compounding quarterly is going to happen 4 times a year. One thing we should remember to do with our rate, with that r value, is we have to turn it into a decimal. Right now it's a percent, so we need to slide the decimal 2 places to the left. So this is 0.065. And we're going for 20 years, so our t value is going to be 20. So if we start setting up this formula, it's going to be a equals the principal amount, which is our $7,250, times 1 plus r, which is our 0.065, over n, which we said was 4, raised to the power of n times t. So we've got 4 times 20. Now I'm going to grab my calculator to type all of this in. So our p-value was 7,250 times 1 plus r, which is 0.065, over our n value of 4. We'll close off these parentheses, and then we have to raise this to the power of 4 times 20. And when we do all that, we should end up with $26,325.87 if we round that to 2 decimals. In part B, when we're doing this monthly, that's going to change our n value to 12, but nothing else should change. We're still dealing with that 0.065 for our r value, and our time is still 20 years, so the only thing that needs to change in our formula is the n value. We're going to make that 12 instead of the 4 that we were dealing with before. So we end up with 7,250 times 1 plus 0.065 over 12, raised to the power of 12 times 20. And again, I'm just going to type this stuff into my calculator. So here's my formula with everything typed in. When I hit enter, I get $26,509.24 if we round that to 2 decimals. For our last one, this one's being compounded continuously, so we have to use our other formula here. So this is where we go a equals p times e raised to the power of rt. We're going to use the same r value, that 0.065, and we're going to use that same t value of 20. So we've got 7,250 times e to the power of 0.065 times our 20 years. And again, I'm going to type this into my calculator. So 7,250, our e to the x is right above the ln, so we go second ln, and our power is going to be 0.065 times those 20 years. And when we hit enter, we should get $26,602.40 for that one. Taking a look at problems number 9 and 10. These ones are kind of related to each other. We're going back and forth between writing things as an exponential equation versus writing them as a logarithmic equation. So what we're going to do is, if we've got something that's written as a to the y equals x, which is sort of like we've got here in number 9. In order to take that and rewrite it as a logarithm, that a value becomes the base of our logarithm. That x value on the right-hand side becomes what we're taking the logarithm of, and then that y value that was the power becomes what this logarithm is equal to. So taking a look at this exponential, the 2 base is going to become the base of our logarithm. This 8 on the right-hand side becomes what we're doing the logarithm of, and then this 3 power becomes what this is equal to. Number 10 is working the other direction. This time we're given the logarithm and we need to rewrite it as an exponential. So this base 2 on our logarithm becomes the base of the exponential. The 4 on the right hand side becomes the power on the 2, and this 16 becomes what this exponential is equal to. So 2 to the 4th equals 16. In number 11, we're asked to evaluate this logarithm using common logarithms and natural logarithms. And the reason we're doing this is because not everybody has a log base button on their calculator, so it's important to be able to use these base 10 logarithms and natural logs instead of this base 5. So when we're doing change of base formulas, if we've got log base a of x, what we do is we take the log of x divided by the log of a, or the natural log of x divided by the natural log of a. So if we were to set this one up using common logarithms, we'd go log of 140 divided by log of 5. And if we were to set this up using natural logs, we'd go natural log of 140 divided by natural log of 5. No matter which way we type this into our calculator, we should get the same exact answer. So there's both of those answers, log of 140 divided by log of 5, and we get 3.070. And if we do the natural log of 140 divided by the natural log of 5, again, we get 3.070 as our answer. 12 through 15 is all about using those different properties of logarithms to expand these out and simplify our expressions down. So number 12, we're looking at the natural log of e squared divided by 5. Since this is division, we're going to use that quotient property to split this into a subtraction problem. So natural log of e squared minus the natural log of 5. Now this e has a power on it, so we're going to use our power property to drop that power down in front. So we get 2 natural log of e minus the natural log of 5. And then the natural log of e is just 1. So if we take 2 times this 1, we get 2 minus the natural log of 5. There's not any simplifying that we can do with the natural log of 5, so we're just going to leave this as our answer. For number 13, where we're looking at log base 5 of 175. Since this is a base 5 logarithm, we're going to look at this 175 and see if we can rewrite it using some 5s. And 175 is 25 times 7, but 25 we can write as 5 squared. So we've got 5 squared times 7. Now since there's multiplication happening, we're going to split that into addition. So log base 5 of 5 squared plus log base 5 of 7. Now this 5 has that squared power on front, so we're going to drop that in front. So 2 log base 5 of 5 plus log base 5 of 7. Log base 5 of 5 is just 1, so 2 times 1 is 2, plus this log base 5 of 7. And again, there's no more simplifying that we can do there, so this is just our answer. On number 14, we've got log of 2 times x to the 4th. With that multiplication, let's split that into addition, so we get log of 2 plus log of x to the 4th. With that x to the 4th, we're going to drop that 4th power down in front, so we get log of 2 plus 4 log of x, and no more simplifying we can do on that one, so there is our answer. With number 15, we've got division happening, so the first thing I'm going to do is split that into subtraction. So log base 4 of the square root of x minus log base 4 of 64. Now I'm going to make changes with each one of these. We don't have a property that tells us how to deal with square roots, so I'm going to make that a 1/2 power. So we've got log base 4 of x to the 1/2 power. And with the second one, this is a base 4. So we're going to look at the 64, and we're going to rewrite 64 as 4 cubed. So we've got log base 4 of 4 cubed. And we can drop each one of those powers down in front. So we get 1/2 log base 4 of x minus 3 log base 4 of 4. And that last log base 4 of 4 is just going to turn into 1. And if we take that 3 times the 1, we just end up with a 3 on the back end. So we get 1/2 log base 4 of x minus that 3. Last section is working in the opposite order. Now we're taking these properties of logarithms and using them to condense down and simplify some of these expressions. So looking at number 16, we've got 3 natural log of x minus 1/3 natural log of y. Each one of these has a number in front, so we're going to take those numbers in front and we're going to bring them up as powers on our variables. So we get the natural log of x cubed minus the natural log of y to the 1/3 power. Now earlier we talked about the square root being the same thing as a 1/2 power, so a cube root is going to be the same as this 1/3 power. So this is the natural log of x cubed minus the natural log of the cube root of y. And then since we have subtraction happening, we're going to condense these down into a division problem. So we've got the natural log of this x cubed is going to go on top of the fraction, and the cube root of y is going to go on the bottom of the fraction. And we're just going to leave that as our answer. For number 17, I see this 7 in front of this second logarithm, so we're going to bring that up as a power on our y. So we get log of x plus log of y to the 7th power. And then this addition we're going to condense down into multiplication, so we get log of x times y to the 7th power. And again, we're going to leave that as our answer on this one. For number 18, we've got log of 25 plus log of 4. I don't see any numbers to bring up as powers, so I'm going to take this addition and condense it down to multiplication. So this is log of 25 times 4, which would be 100. Now we have to stop and think. This log is a base 10 logarithm, and there are some 10s inside of 100. We can rewrite this 100 as 10 squared. So we've got log of 10 squared, and we can bring this squared power down in front to get 2 log of 10, and then log of 10 is just 1, so if we take 2 times this 1 on the end, we just get 2 as our answer. Last one, number 19, we've got a half log of x plus 4 log of x minus 1. With each one of these numbers, we're going to bring them up as powers, so we get log of x to the 1/2 power plus log of x minus 1 raised to the 4th power. This half power is the same thing as a square root, so that's log of the square root of x. And there's nothing we can do to rewrite that second one, so that's just going to stay as log of x minus 1 raised to the 4th power. And then last thing we need to do is take this addition and condense it down into multiplication. So we get log of the square root of x times x minus 1 raised to the 4th power. That's going to be it for this video. Thanks for watching.